What we're looking at is a legacy of the Ice Age. Permafrost and methane is a time machine. So what we're going to do is walk back in time. We're going to see old carbon, old bones, old environments, and none of those are in equilibrium with today's climate, so that's the problem. That world doesn't exist anymore, and it hasn't for 10,000 years. It was nicely and very delicately separated from this modern warmer climate by about this much moss. And when that moss goes away, whether for fire or for human disturbance or for warming, then all hell breaks loose.
Permafrost. It's maybe the part of the cryosphere that's most out of sight and mind. It's fascinating how it formed in the first place and how it got loaded with so much carbon. In a minute, we'll go back underground with Matthew Sturm from the University of Alaska Fairbanks. But first, let's meet Peter Griffith, NASA's project manager for the Above campaign, which supports more than 70 science projects studying forest and tundra vegetation, wildfires, animals like birds, caribou, and Dall sheep, methane emissions from expanding northern lakes, and the impacts of climate change on people in Alaska, Canada, and around the world. Many of those projects have some direct connection to permafrost.
Permafrost is the hidden cryosphere. It's the permanently frozen soil that surrounds the Arctic, all across Alaska, northern Canada, and then across Eurasia. The ground has been frozen during the ice ages.
During the ice ages, there was not enough snowfall in the drier regions of Alaska and Canada to form glaciers there, so the land was suitable for vegetation.
What happened is that over thousands and thousands of years, all of that plant material got compacted and frozen every winter and buried and pushed down, so that today there's 300 feet deep of frozen water and dead plants and some pieces of dead animals too. Sometimes you find woolly mammoths in the permafrost. But most of it, of the organic matter as we call it in the permafrost, is frozen plant material.
Some of that plant material is now thawing and decaying, releasing its ancient carbon into the atmosphere, sometimes in the form of methane gas bubbling out of expanding northern lakes.
We started this field campaign because the Arctic is the part of the planet that is warming first and fastest. And there are consequences to this for permafrost. So during the Arctic Boreal Vulnerability Experiment, we're studying permafrost with people on the ground, from aircraft flying over the region, and also from satellites in space.
Another way to understand the permafrost is to take a walk below ground with Matthew Sturm and into the U.S. Army Corps of Engineers permafrost tunnel.
And they've dug this tunnel back into the side of a hill about 200 feet, and it goes sort of sloping down so that by the end of the tunnel you're about 100 feet underground, and you're surrounded by bones sticking out of the wall from the steppe bison and the mastodons that are frozen in it. There's sticks that are 40,000 years old, that you can touch with your hand. There's grass that's still green, that's tens of thousands of years old because it got frozen, right away, and it's never lost the green color.
But as fascinating as it is to see these relics of an ancient era, or to see a tree split in half by thawing soil, or even to light a ball of methane on fire from under winter ice, at the end of the day, Peter and his colleagues want to know just how much organic matter is frozen in that permafrost, and how fast it might be released.
Currently, we think that there is something on the order of 2 to 3 times as much carbon locked up as frozen organic matter in permafrost as there is carbon dioxide in the atmosphere. So releasing all of that organic carbon from permafrost into the atmosphere would be a real game changer. That would be a tremendous transformation of the planet's atmosphere. Now, the good news is that it would take a very, very long time for that to happen. However, we are warming the planet at a rate now that calls into question how quickly is that changing and what the consequences in the near future and in the far future are going to be.
You're in the middle of a field somewhere in California at 4 a.m. It's sort of surreal in a way, because you've put so much time into it for so long, and actually seeing it over there is like, whoa, you know, it's a big deal.